Hello, in today's video I'm going to be talking about momentum. Specifically, I'm going to define momentum, then I'm going to talk about the relationship between force and momentum, as well as the conservation of momentum, and finally, different types of collisions. So starting off with the definition of momentum, I would define momentum as a vector quantity which measures the how hard it is to stop an object from moving. And this is often denoted by the symbol P, like this, and the formula is mv, where m is mass and v is velocity. So force and momentum, next I'm going to talk about how force and momentum relate to each other. Essentially, the rate at which an object's momentum changes is directly proportional and in the same direction as the applied force, which can be mathematically described or modeled by the following equation. Force is equal to the derivative of momentum. Some people like writing it as a derivative of mv, but I mean it means the same thing given the equation up here. Next, I'm going to talk about conservation of momentum. Essentially, when in an isolated system where there are no external forces, linear momentum is always conserved. So essentially, momentum initial is equal to momentum final. It's pretty straightforward. Next, I'm going to talk about collisions. So I would define a collision as an event in which two or more objects approach and interact strongly for a brief moment or period of time. There are different types of collisions. The first one I'm going to talk about is elastic collisions. Essentially, an elastic collision is when two objects collide and they bounce off of each other, whereas an inelastic collision is when the objects don't bounce off of each other and the kinetic energy is not conserved. Now that we have a basis on all of these different types of collisions and momentum and force, I'm going to go ahead and apply these concepts to a specific example from an AP exam. So first I'm going to read the prompt. Blocks A, B, and C are aligned along a straight line on a horizontal frictionless surface. The masses of the blocks are m, 2m, and 3m respectively. Block A is initially moving to the right along the same line at speed v, as shown in the figure above. Blocks B and C are initially at rest. Block A collides with and sticks to Block B. The two blocks then collide with and stick to Block C. What is the speed of Block C after the collisions? So I'm going to go ahead and draw the diagram for you. So we've got our horizontal frictionless surface here. We've got Block A, then Block B, and finally Block C. And we're given that Block A has mass m, Block B has mass 2m, and Block 3 has mass 3m. So we know that since we know that momentum is conserved, we can go ahead and apply that the sum of all the blocks is going to be equal to the momentum of the whole system. So I'm going to go ahead and write that down using this formula. So we've got m times velocity initial, I'm going to say v1, plus 2m times, we know that Block B is at rest, so it's going to be, the velocity is going to be 0, plus 3m, again, same thing as Block B. Block C is at rest, so velocity is 0, is equal to the mass times the velocity, so the total mass, you could say. Okay, and then after collision of A and B, we know that mass times V1 is plus 2 times mass times V2 is going to be equal to, again, block C is still at rest. We can just completely ignore that. Oh, I'm going to write after collision of A and B, just to clarify, is equal to m times v. Just to simplify this out a little bit, make it a little easier, we can say that, so these velocities are going to be the same because when block A collides with block B, an inelastic collision is going to occur, and so the velocity is going to transfer over to block B. So we have V, these are technically both V1, so V1 times m plus 2m is equal to mv. So now, again, both blocks A and B are moving together with velocity v1. And now we're going to look at the velocity after the collision with C. So, after the collision with C, it's going to be, velocity 1 is m plus 2m plus 3m equals mv. Again, we're trying to solve for what that velocity is going to be. So we can just go ahead, this is going to be a different velocity, so velocity 2. We can go ahead and equate the two to each other and get v1 times m plus 2m is equal to v2 times m plus 2m plus 3m. And following some very simple algebraic problem solving, this should simplify out to 3m times v over 3 is equal to 6m plus v2. And then if you solve for v2, subtract by 6m, simplify everything out, you should get v2 is equal to velocity 1 over 6. And then we go ahead, velocity 1, I guess this problem treats as just simply v. So let's see, that corresponds to option B. So option B is going to be the correct answer to this one. Thank you.